Roots are the inverse of exponents. The square root of 25 simply means what number multiplied by itself equals 25, which is 5. The square root of a number always refers to the positive square root. The cubed root of a number means the number that is multiplied by itself 3 times to equal the number under the radical. In the case of 64, 4 times 4 times 4 equals 64. You cannot add or subtract roots unless they have the same number under the radical. So in the case of the square root of 25 plus the square root of 16, the answer is not the square root of 41. Instead, the answer is 5, the square root of 25, plus 4, the square root of 16. Only like radicals can be added or subtracted from one another. As you can see in this example, the radicals with bases of 5 can be added together, and the radicals with bases of 2 can be added together. But you can't simplify any further. So you're left with the square root of 5 plus 3 root 2. To multiply roots, you simply multiply the numbers under the radicals together. So root x multiplied by root y would give you a product of root xy. Let's try this with integers. Root 3 times root 5 would simplify to root 3 times 5, which gives you root 15. Dividing roots works in a similar way. Root x divided by root y is simply root x over root y. The square root of 49 divided by the square root of 25 would be root 49 over root 25, which simplifies to 7 over 5. Roots can be simplified by finding perfect square factors for the number under the radical. For example, let's take the square root of 72. We know it's not a perfect square, so our initial instinct may be just to let it be. Instead, let's take a look at its factors. We've got 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. You can see that there are 3 perfect square factors, 4, 9, and 36. We're looking for the biggest one, which in this case is 36. So now we can rewrite the square root of 72 as the square root of 36 times 2. We know that 36 is a perfect square, so that allows us to pull out a 6, leaving us with 6 root 2. Let's try another. Square root of 96. Again, let's take a look at the factors. 1, 2, 3, 4, 6, 8, 12, 16, 24, 32, 48, and 96. See any perfect square factors? 2 this time, 4 and 16. Remember, we're looking for the biggest one, so we'll grab 16 and rewrite 96 as root of 16 times 6. We'll pull out the perfect square, 4, and we're left with 4 root 6. Let's take a look at some sample problems. Root x over y plus root y over x is equivalent to which of the following? To solve this problem, think back to our basic properties of operations with fractions. To add them, we need to determine the least common denominator, which in this case would be xy. So we multiply the left side by x over x and the right side by y over y. This simplifies to x root x over xy plus y root y over xy. Now we can add the numerators together, and we're left with x root x plus y root y over xy.
Let's try another. Column A is the square root of 27 over the square root of 3. Column B is the square root of 45 over the square root of 5. What is the relationship of the two quantities? Let's start by factoring each column. Factoring the square root of 27 gives us the square root of 9 times 3 over the square root of 3. Factoring column B gives us the square root of 5 times 9 over the square root of 5. Remember the rule of multiplying roots. The square root of a product can be rewritten as the square root of each individual factor multiplied together. This means we can rewrite the square root of 9 times 3 as the square root of 9 times the square root of 3, and the square root of 5 times 9 as the square root of 5 times the square root of 9. Now we are able to cancel out the common factors of the resulting fractions, leaving us with the square root of 9 in each column. The two quantities are equal.